Hey guys, today we're going to be talking about 1-8, which is talking about graphs and functions. And today what we're going to be doing is kind of writing a little story about each little graph. So some vocab we're going to go over is a function, is a relationship between an input and an output. An input would be an x value, an output would be a y value. A coordinate system is a function is graphed on it. Y-axis is your vertical axis, that's your up and down. Your x-axis is your horizontal axis. An independent variable is your x value. It causes change. Okay. The origin is at 0, 0. An ordered pair is written x, y, which is alphabetical, something we should know. A dependent variable is the same as your y. And domain and range, domain is the same as the x value, and range is the same as your y value. So some stuff to go over. First off, the point on a graph is at day 2 along the x-axis. So if you look here, here's our graph. Day 2 along the x-axis and is about 80% along the y-axis. So about 80 up. So 2 over, 80 up. This represents 80% normal blood flow in 2 days after surgery or after injury. Okay, if you were to write that as a coordinate, this coordinate right here would be 280. In the example, the percent of normal blood flow depends on the number of days. Okay, so that is why it is called a dependent variable. An independent variable is something you can control. You can control what time you do something. You can control how long you do it for. You can't control what the result is. So let's say I was going to school. I could control how fast I was driving to school. Okay, I could go 40 miles an hour. I could go 60 miles an hour. What I can't control if I do that is how long it's going to take me. My speed limit is my independent variable. I can control my speed limit. I can't control how long it takes me or if people are going to get upset about it. Okay, so every graph we do today, the bottom, when you have to write it out, we're going to label it time. Okay, and then we got to figure out this other label based off what they're asking us to do. So the graph to the left represents the speed of a school bus by traveling along its morning route. Describe what's happening in the graph. So there's no graph here, obviously, so I have to draw it in. So let's just say it's going, we're going to say this is speed. Okay, as we driving along. So when we look at this, as you can see, our bus is starting out at normal speed. We don't know how fast it's going, but it's driving along. Okay, and then it starts to slow down a little bit, and then if you look here over time, it's not going any speed, which means it stopped. So if you look, our bus is driving. It's starting to slow down because our speed is going down. It stopped because our speed isn't moving, and then our speed starts to pick up again because he's driving away, and then he's going the same speed. So that's basically what we're doing today is we're going to be trying to interpret graphs per se. So this one obviously doesn't have graphs, so I'm going to draw them in real quick. Identify the graph that represents the altitude of a space shuttle above Earth from the moment it is launched until the moment it lands. So we're going to go time, and I'm going to go height. Okay, so we're going to start with this one. We'll go with this one, and then we'll go with this one, like that. So if we're looking at these three, which one would say that we launched a space shuttle above Earth, and then it comes back down and lands? So if we look here, the height. Our space shuttle started way up here, right? The space shuttle is supposed to start on the ground, so it can't be this one, okay? Because this one is launching it 100 feet in the air. This one is starting on the ground and goes all the way up. But if you look at it, if you read the sentence, the moment it lands, this one doesn't show it's landing. So this one, if we look right here, it starts on the ground, it's launched in the air, it stays in the air for a while, and then it crashes back down to Earth, and then it's at ground level. So our best bet would be right here. Okay. Now, when we're looking at this one, drawing graphs. So So an electronics store is having a sale. For every 2 DVDs you buy at $29 each, you get a third one free. So if I bought 1 DVD, it cost me $29. If I bought 2 DVDs, it cost me $58. But then if I buy 2, I get that third one free. So then I get $58 still. And then the same thing here. Next one would be 87. And then after that would be 106. 116. And then our third one's going to cost 116. So if you were to graph that, looking at your notes, this would be, now we got to figure out which is our X and which is our Y. So if we're looking at it, can I control the cost of a DVD or can I control the cost of how many I buy? Well, I can control how many I buy. I can't control the cost. I can't go to Walmart and be like, I want that DVD for $5. No, you go to Walmart, a DVD, Blu-ray, whatever's going to cost you however much, you don't get to pick the price. You get to pick how many you buy. So we're going to say this is the DVD number. And this is the cost. Because we can control how many we buy. That's why it's an X value. We control it. The cost, we don't control. So that's a Y. So if you're graphing them, 129, 258, 358, 487, 5116, 6116. Our graph is going to look like this. All right. So that is it for today. Hopefully that makes sense. Like I said, ask questions, guys. Today, when your homework, you're going to be looking over how to interpret graphs. So they're going to have them for you. You have to tell me the story that's going along. Okay. Thanks, guys.